I don't have a video for part 5a, so I'm going to redo it. Okay, so I've just finished question 9, and question 9 will be at the start, well, I mean at the end of the video. So, we're given this equation, 2x cubed. I'm going to use my blue pen. Minus 3ax squared, minus 3ax squared, plus bx, plus 8a. Okay. Given that x minus 4 is a factor, use the factor theorem to show that 10a equals 32 plus b. Okay. So x minus 4 is a factor. So x minus 4 is equal to 0, x equals 4. And now if we plug in the values of 4 in the x's, minus 3a, 4 squared plus b, 4 plus 8a, we get the value equaling to, just going to cheat over here, 128 minus 48a, plus 4b plus 8a. Okay. And now if we tidy everything up, we would get 128 minus 48 plus a would leave us to minus 40a, plus 4b is over here. Now if we put, because it wants us as 10a equals to 32 plus b, we want to put a over here, leaving us with 40a is equal to 128 plus 4b. If we divide each side by 4, we're left with 10a is equal to 32 plus b. There we go. That the equation stated is 2x cubed, although we've got the black pen this time, I actually found it, minus 3ax squared plus bx plus 8a. So from the start we know that x minus 4 is a factor, right? We know that already. If I just bring this guy a little closer, okay? Hopefully you're able to see that, okay? Perfect. So we know x minus 4 is a factor. We worked out what happens when we substitute it. So if I just move this all the way to that side, when we substituted it, we got this. So 10a equals 32 plus b. Okay, that's what happened when we substituted it. But then what we did next, well, that's where we ended off. But in the next part, on question B, we're also told that x minus 2 is also a factor. Okay? So, it's telling us x minus 2 is also a factor. So in this kind of scenario, we do the same thing. So, x minus 2 equals 0. X equals 2. And then we do 2 cubed minus 3a2 squared plus b2 plus 8a. We should get 16 minus 12a plus 2b plus 8a. Tidying that up, we get 16 minus 12a plus 10 with 4a plus 2b. Tidying up that even further, we should get 16 minus so if we just simplify it, and add a 0, so if we add a 0, we get 8 minus 2a plus b. If we put 2a over here, we get 8 plus b. Okay, That should not be a 6, that should be a b. Okay, so for this one, we got 2a plus 2a equals 8 plus b. Okay, so that is what happens when you factorize that. Okay, and now we're told another piece of information that it wants us to express f of x in the form 2x plus k, x minus 4, and x minus 2. Okay? Now, this looks a bit too diagonal, so it's 10a equals 32 plus b. That should be fine. Okay? And then we're told that there's another one where it's 2, what was it, 2x plus k? Yeah, 2x plus k. Okay? So, if you think about it technically, and this is where our logic starts to apply, this is technically the same as that. So let's do that. So if we make, and, okay, before we do all that, we need to find out the values of a and b. So we can pop that over there so it's less confusing. So we actually find out what k would be by decreasing the number of unknowns. So the way we find out what a and b are is we got two values over here, right? Two unknowns and two equations. What do? We do simultaneous equations. So we're going to do a type of simultaneous equation. It's sort of like y equals y, but this time slightly different. Okay, just drop my chemistry poster over there. Anyways, so to make it y equals y, we have to make two unknowns the same. So to make the two unknowns the same, this is a 2a and this is a 10a, so we times this by 5. We get 10a equals 40 plus 5b. Now we make them equal to each other. So 32 plus b equals 40 plus 5b. Okay, and now we work out what b would be. Tidying that up, we get minus 8 equals 4b, and then finally b equals minus 2. Okay, so we know b is minus 2. Now we substitute b as minus 2 in this equation. We can do it in any equation. We can pop it here, here, here. It doesn't matter. We'll still get the same value for a. 8 minus 2. And then we get 2a equals 6. And then a is equal to 3. So we've got two values for a and b. And we plop them over here. So if 3 times 3, so that would be 9. And then b, that would be minus 2. Minus 2x. And then a would be minus 3 times 8 would be minus 24. Sorry, plus 24. Okay, so that's our equation now. Now if we remove all this, okay, should have used a rubber there. There we go. Okay, so we know that this is equal to that. So let's make it like that. Okay, so if we get 2x plus k, and then x minus 2 and x minus 4 equal to this, well, first things first, we need to find out what these two are multiplied together. So we're going to multiply all of them together, okay, and then we're going to equal it to that, and then we're going to simplify it by taking each other away and things like that. If you can see what I mean, I'll just show you. So x minus 4, x minus 2, x minus 4. I'll actually do the box method, me. X squared minus 2x minus 4x, and then that would be 8. So that would be equal to x squared minus 6x plus 8, and that would be 2x plus k. Okay, and that would be the same as that. But if we multiply it even further, making it closer to that, I know this is a bit slanted, and we make it less slanted now. X squared minus 6x plus 8, we get, and then 2x plus k. Alright, And now, if we multiply all of these together, 2x cubed minus 6x, that would be minus 12x squared, and then that would be 16x, and then we get 8k minus 6xk, and then that would be kx squared. Okay, so that would be our answer for this one, making that. I'm going to remove the bracket now because we've multiplied it. If we multiply something fully, we don't use the bracket anymore. So 2x cubed minus 12x squared plus kx squared minus 6k. Let me remove this. Plus 16x plus 8k. Alright? So that's our answer for that one. Okay? And that would be equal to that, so let's put that on the bottom. 2x cubed, we might minus it. Actually, I'll make this a little shorter. So that would be equal to 2x cubed minus 9x squared minus 2x plus 24. Okay? These and these would cancel out. Minus 9x squared, minus 9x squared. Well, minus 9x squared is the same as minus 12x squared plus kx squared. Now the x squares would cancel out in this kind of scenario. And then we that should be wrong. Then we would know that k would have to be 3, okay, because minus 12 plus 3 is equal to 9. Okay? And that should be it. Yeah. So, now, if we bring this back, we take all of this away, we go back to the original question, finding out what k is. K is 3. Sorry, I froze a little there. I thought it was like 21 for a sec, it's actually 3. So yeah, that's question B right there. Being, I know it's a bit slanted, 2x plus 3, x minus 2, and x minus 4. Hopefully that works out. Yep. Would you believe I'm balancing this iPad, the one that I'm recording with a boxing glove? Anyways, so CI states, state the number of real roots of the equation f of x equals 0. We know that 1, 2, 3, that would be 3 roots. And you have to say 3 roots. So part II states, write down the largest root of the equation f, 1/3 of x. Now, if we get all of these, we would get, and we make them, we find out what x is equal to. X would equal to 2 in this one. X would equal to 4 on this one. And x would equal to minus 3 over 2 for this one, right? That should make sense. I don't know why there's a glare over there. Should be better. Okay, so this is x is equal to minus 1/3, and minus 3 over 2, and then x equals 2, and x equals 4. Now, what we do is we find out what f of 1/3 of x is equal to. Now what that means is, you know how we were talking before in a previous video, that whatever you do with the x, you do the opposite. Okay? It's the same case. We don't divide it by a third, we times them all by 3. So instead of timesing it by a third, we divide it by a third. Okay? So this would be times by 3, or x equals 12, x equals 6, and this would be x equals what? Minus 9 over 2. Okay? And it's asking us to find the largest root, and that would be x equals 12. That's your answer for part C. So we're starting 6a, and it's asking us to find PQ. Find PQ. Okay? So how are we going to do that? We're given 2 data points, P and Q. We're trying to find from P to Q, right? P to Q. Now, I would say the best way to work it out is by plotting it in a graph. And we know that we go 9 over here and minus 8 over here. We get P being over here. Okay? From O. So we find it over here. And Q being 3 and minus 5. So this would be minus 5. Would be over here. Okay, so P to Q, to find that out, we need to find out O to P. So minus O to P. So this would be O being 0, 0. And then to P, and then to Q. So from here, and then all the way to here. So minus O to P. Okay, that would, and then plus O to Q. Should be right. That gives us P to Q being, well, minus O to P would be minus 9 minus 8, so plus 8. I'll just remove that. Plus O to Q being 3 and minus 5. P to Q would be equal to minus 6 and 3. Should be right. So P to Q minus 6i plus 3j. Okay? Okay, so this is question 6b. This took me quite a while to work out, I won't lie to you, but this is how I managed to work out the solution, okay? So in the question we're given PQ and we're given QR. Now the first thing I did was I plotted where Q, P and R would be, okay? So P would be over here following the coordinates from the first question. This would be P. Q would be here following the coordinates from the first question. And then following the coordinates that we're given in this question, QR would be 9i plus 18, 9 and 18. It would be about here, okay? So in this way, it's making a triangle. Okay? Well, it's not the best looking triangle, but I'm trying here. Right. So it's telling us that PQR, so this is R, PQR forms a 90-degree angle. Now, 90-degree angles, the only thing that would work with 90-degree angles, well, one of the things that works with 90-degree angles is Pythagorean theorem, right? Thing is, you got to know this, right? If it's a 90-degree angle, Pythagoras can work with it, okay? So what do we have to do in order to prove that this is a 90-degree angle? Well, it's quite simple, actually, okay? We have to find out the length of that and that, and then use Pythagoras to prove that these two lengths is equal to the same length as that. So let's find out what this length is, P and R, okay? By doing that, we can find out what this is, so we can prove that these two, when we do Pythagoras, we can prove that that is kind of why it's 90 degrees. Because if we can do Pythagoras on it, it proves that it's 90 degrees, if that makes sense. Okay? So starting off, we got P to Q and Q to R. We want to find out what P to R is, okay? To find out what P to R is, so if I write it down here, P to R, we need to go from P to Q, P to Q, and then Q to R. Q to R, we got it over here, plus Q to R. Okay? So P to R would be, I'm going to make it in fractions just to make it a little bit easier to see. It's not called fractions, but I call it fractions, but it's not really. So if I do it like that, P to Q would be -6, and J would be 3, and then Q to R would be 9, and this one would be 18. Okay, so P to R, if we add it all together, -6 plus 9, that would be equal to 3. 3 plus 18, that would be equal to 21. J. Okay, and to find the length, we have to find the magnitude of this. And to find the magnitude, we have to do Pythagoras again. Not confusing it with the Pythagoras we're doing here, but kind of to find the length. Just one of the rules with vectors. So to find this length, PR, we have to do 3 squared plus 21 squared, which gives us PR, and that would equal to root 450. Okay, so now we know that this is root 450. Okay, that's step 1. Now, step 2 becomes a little bit easier. Okay, so now we know what P to R is. The next step is to find the length of that, and then do Pythagoras to prove that it makes that. Okay, and to do that, we need to find what P to Q is. So if we do the same thing, doesn't matter if it's a minus or a plus, it will still give us the same answer. -6 squared plus 3 squared. Let's make that bracket a little longer. Not bracket, you know, with one in the root. And that would equal to root 45. That is equal to root 45. Okay. And now we find out what Q to R is, which is the same way by doing the magnitude of it, which is 9 squared plus 18 squared, which gives us root 405. Root 405. Okay, so now that we found the two lengths, okay, we can finally prove that if we do root 405 squared plus root 45 squared, it should give us root 450. Okay, so if we do square root 405 squared plus root 45 squared, because remember Pythagoras is a squared plus b squared equals c squared. This is our c squared. This should give us root 450, which is equal to roughly 21.21, I believe. So if I find me a calculator anywhere, if I actually can find a calculator, let's just check the answer. And according to the answer, yep, that's right. So that's hence how we can prove that that is a 90-degree angle. Hey guys, a bit of a different scene. I know it's quite the morning. So we're going to start off with question 6C. Okay. And we're given a new kind of value. So we are given P to S. Okay. So the question states, given that S is the point such that P to S equals 3Q to R. Okay. Find the exact area of PQRS. So from the previous kind of question, we know that P, which is here, Q, I'm just roughly estimating here, Q, and then we know R is here, we know P2S, which should be somewhere here, right? Because if Q to R is 1, so if this should technically be a little bit smaller. This is 1, and this is 1, 2, and 3. I know it's not the best kind of length, but it's kind of like what it is. So if we just link them up all together, no, it's not the best lineup. It gives us a sort of trapezium, okay? So we know that Q to R is root 405 from the previous question. This would be root 45, same thing. But we also know that P to S is 3Q to R. Q to R, if we times that by 3, we get 3Q to R. 3Q to R would be 405. So we just times that by 3 pretty much, because that length is 1, and this length is 3 times that. So 3 times 1, this gives us 3 times the value. Okay? So to work out, now it's telling us to find the exact area of PQRS. To do that, we have to find out the area of the trapezium. So the formula for the area of the trapezium is half A plus B H, all times H. Okay? So this would be our A, and this would be our B, and this would be our H. So we do half root 405 plus 3 root 405 times H, which would be root 45. And that would be our answer, giving us 270. And that is the exact area. Okay? Okay, now we are performing question 7. Okay? Hopefully that is clear enough. Question 7 states the binomial expansion of 1 plus ax to the power of 12, okay, up to and including the term x squared is 1 plus, sorry, there should be minus 15 over 2 x plus kx squared. Kx squared should be right. Yeah. Okay. So this is our equation. Okay. If I make that a little bit clearer. Okay. Should be clear enough. If I bring that a little bit closer, yeah, makes things a little bit easier. Okay. So we're trying to find the expansion of the x coefficient, power, to be to the power of 2. So the way we do that is by using C. Okay? So starting off, we got 1 AX. We're going to find that 1 AX. It's 1 AX. And this is kind of the way I do it. Put C over there, C over there, C over there, until there's a 2 over here. So this would be 0, 1, 2. This would be 12, 11, 10. And our C would always be 12, because this is 12. Okay? And then our C would always increase. So 0, 1, 2. Okay? So working it out should be pretty simple. That 12C0, if we put that in the calculator, we should get 1, and 1 times 1 to the power of 12 would always just be 1. Okay? As 12C1, that would give us 12, and 12 times 1 is still 1 times ax would give us 12 ax. Okay, next one. I don't know this one. We have to put this in the calculator. To do that, well, it would give us 66. Okay, so this is 66. Let me just tidy this up a little. 66a squared x squared. Let's just double check that that is right, and that is. Okay, so it's telling us that this kind of equation is the same as this equation. Okay, so rubbing out all the working out, sorry for the noise, we would know that that is equal to that. So technically this, considering the x is same, is the same as this. Okay, we can't really work out this one. It's more difficult to work out since there's two unknowns. This one only has one unknown, so we can work out this one. Okay, so let's work out what a is. All right, so we would use minus 15 over 2 equals 12a. Okay, I'm just going to rub out the rest because we're only trying to find out what a is. Okay, and then hopefully that didn't turn around too much. Let's just double check that's right. Yes, it is. Times 2 to each side, giving us minus 15 equals 24a. And if we do divide by 24 on each side, we should be left with a is equal to what is it? 5 minus 5 over 8 minus 5 over 8, and that is our answer for A. Okay, starting off question 7b. Okay, we're told that we should find what k is, so we have to find out the value of k. Now we know previously that we got 1 plus 12a x plus 66a squared x squared. Okay, and now we know that this value is the same as this value because they have the same x squared. So this is x squared and this is x squared, and we're told that these two are the same, so we can confidently assume that that is the same as that. Okay, so 66a squared is equal to k. Alright, we know what the value of a is now from question A, part A, sorry, so we could just do this. Squared equals k. And now whatever value we get on this one, we will find out what k is. So k is equal to, pulling out our calculator, 66 minus 5 over 8 squared, which gives us 825 over 32. Okay, that's our value for k. So we are now on part C. Okay, and on part C it states, find the expansion of 17 over 16 to the power of 2. Okay, working this out quickly, we know that, power of 12, not 2. 17 over 16 is equal to this. Ignoring the powers, we would get 17 over 16 is equal to 1 plus ax. Now, we found out the value of a from the start of the question, so if we just plug in the value of a, we would get 17 over 16 is equal to 1 plus, not plus, minus 5 over 8 x. What we do now is we take out, we're trying to find out what x is. So if we take out 1, we should get 17 over 16 take 1 equal to minus 5 over 8 x. Then if we divide everything by minus 5 over 8, so we just do pretty much this is what we would get. And for x, if we plug that in to our calculator, minus 1, divide that minus 5 over 8, we get minus 1 over 10, which is the same as minus 0.1. Okay, so x is equal to minus 0.1. Alright, our next step would be using that to find the expansion. Right, so getting started, we know that x is equal to minus 0.1. So if we use what we got from part B, we would know that our equation would now be 1 minus 15 over 12 minus 0.1 plus 825, because we found out the value of k, and this is k, over 32 minus 0.1 squared. And now, if we plug in this value into our calculator, we should get, as a rough estimate, because this is only an estimate, we should get 2 to 4 decimal places, because that's what it asked for, 2.0078. For that would be our complete answer for question 7, complete in A, B, and C. Okay, so we're starting this video with question 8. Okay, and with question 8, we're given this graph. Okay, log 10p and 0, 3.1, 3.3, and 6, 2.1, x, and this is our kind of exponential graph, I guess. So, starting off with the question, is telling us find a, b, x. P equals a, b, x. So we're given this kind of equation. Find a complete equation for the model in the form P equals a, b, x. Okay, so if we look at how P is over here and how P is over there, we would know that P doesn't contain a log 10p, but over here we got a log 10p over here. So to make life simpler, we would just put a log 10p over here. And because we made log 10p over here, we have to make log 10p over here as well. Log 10 a, b, x. Okay? So, now that we got this equation, we can separate it out to find out each value of a and b. So log 10p is equal to log 10a plus log 10bx. Okay? Now, if we kind of look at this, we can easily recognize that this equation, this is kind of like an equation of a line, really. Okay? But our x is kind of floating over here as a power, so we can just make this over here. Now, similarly, we can put this over here, it doesn't really matter, right? But just to make it more visually appealing, we would know that this would be our intercept, this would be our gradient. Okay? So, to find out A and B, we first need to find out what the gradient would be. Or we can find out what the intercept would be. It's no big deal, we can find out each one. So we're going to start with B first. Okay? So, if I just remove this graph and put the coordinates over here, we would get 0, 3.3, and 6, 2.1. Okay? That would be our coordinates. And to find out the gradient, we do dy dx or changing y or changing x, it doesn't really matter. Same thing with differentiating. If we differentiate something, we're pretty much just getting the gradient. Same thing with Pythagoras. We find out the hypotenuse, that's also the gradient of something. So if we do dy dx or changing y and changing x, there's a specific equation for this. It's y2 minus y1 over x2 minus x1. And it doesn't matter what our y2 or y1s are or our x2s or x1s are, as long as we value them correctly and plug them in correctly, it should give us the same thing. That's the beautiful thing about mathematics. If it works, it will work no matter what you do with it. So if we make this our x1 and we make this our x2, make this our y1, this our y2. Hey, we can even put this as our y2 or our y1, but never jumble it up. Okay, never put your y1 first and then your y2, or your x2 first and then your x1, and this is all like switched up and confusing. Okay, so over here we would get 2.1 minus 3.3. Okay, and then x2 minus x1 is 6 minus 0. If we plug this in the calculator, we should get a value of minus 0.2. Okay, now this is our gradient. Ignoring this x, this and this would be the same thing. Okay, log 10b is equal to minus 0.2. Okay, using the laws of logs, right, we can make this be 10 to the power of 0.2. Okay, this would still be the same as this. Okay, alright, if we just rub this out, and we also rub this out, okay, it's slightly slanted, do forgive me, b is equal to this. And now we're going to find out what a is. So let's just tidy things up right now. So we know our gradient. Actually, we know our equation. Our equation would be log 10b equal to log 10a plus log 10b x. And we also know our gradient is equal to 10 to the power of negative 0.2. And we also know our, well, we don't know yet actually, our intercept. So y-intercept, or our kind of p-intercept really. So we don't know that yet, okay? And to work that out, it's pretty simple. So this is one law you just have to remember. The y-intercept is when x is 0, is the value of y, or p in this case, or log 10p in this case, when x is 0. So when x is 0, our y, or our p technically, is 3.3. Okay? So looking at this, this would be our gradient, and this would be our intercept. So log 10a, and it shouldn't be capital A, it should be little a, is equal to 3.3. Following this, doing the same steps as this would be equal to a equals 10 to the power of 3.3. Okay? So that's our value of our intercept. Keep in mind, our value of intercept would not be the same if we put 2.1. Because this isn't when x is 0, it has to be x is 0. Okay, this is really important. Okay, so our y-intercept now, we know, is 10 to the power of 3.3. Okay, and now we just plug in the values simply in this equation. We haven't really changed anything about p, so p is still equal to that. Kind of log 10p's like this, but you know, ignoring the logs, removing all the logs, it's pretty much like that. 10 to the power of negative 0.2, that would give us a value of 0.6310. 0.6310. The value of our y-intercept would be 1995. So our p would be equal to 1995 plus 0.6310x, and this would be our equation, landing us 4 marks. Okay, so we're starting question 9 now. Okay, this is our last question technically, which includes part A and part B. Okay, so we're told to find the price per gram of metal B and metal A. So we're given both equations, metal A and metal B. Okay, these are 2 equations, and we have one really key piece of information that tells us VB is equal to VA is equal to 2VA when T equals 0. Okay, that piece of information is extremely key. Okay, so now what we have to do is find out the value of VA, times that by 2 to find out the value of P. Okay, so the value of VB, first of all, would be equal to, well, when T equals 0, so let's just say we made that 0. Okay, made this 0. Okay, when T equals 0, minus 0.02 times 0 will still leave us with 0. So e to the power of 0 will leave us with 1. Anything to the power of 0 is 1. So VB is just P. Okay? And now we're told that P, because VB is equal to P, P is also 2VA. Okay? P equals, well, 2VA. So this is quite simple. Same kind of idea. 0.04 times 0 is 0. E to the power of 0 is 1. 20 times 1 is 20. 100 plus 20 is equal to 120. So this is equal to 2 times 120. And then our value for P would equal to 240. Okay? Okay, so we're doing the last question now of the pure section. Okay? So over here, we told this equation and that equation. We converted P to 240 only because we found out in part A that P is equal to 240. Okay? And now it's telling us this. VA is equal to dVA is equal to dt equal to minus dVB over dt. And this is because it's told us when T equals T, the rate of increase in the price of per gram of A, the rate, when we're talking about rate, we differentiate. Rate, differentiate, okay? Per gram of metal was equal to the rate of decrease, there's a minus, in the price per gram of metal B. This is metal B, this is metal A, decrease in metal A, okay? Rate of decrease, okay? Find the value of T, given your answers to 1 decimal place. Okay? So we're told that T equals T, capital T over here, okay? This is pretty important. Alright. So the way we differentiate this, okay, is when we differentiate, the 100 disappears. So we do 20, 0.04 times e to the power of 0.04t. That leaves us with 4 over 5 e to the power of 0.04t. And the thing is, when we differentiate exponentials, the power does not change. Okay? We still times it, but the power does not change. Okay? So that's our first one. So we get 4 over 5 e to the power of 0.04t. Okay? Now for the next one, we do the same thing, 240 to times 0.02t, not 0. We don't put t, by the way, just saying. E to the power of minus 0.02t. Okay? So this would leave us to 224 minus 24 over 5 e to the power of minus 0.02 t. Okay? So this is our value of the metal B. So minus 24 over 5 e to the power of minus 0.02 t. Okay? Minus times a minus gives us a positive, so we're left with this. Okay? And now we got both sides having 5. We can cancel them out by timesing each side by 5, leaving us with 4 e to the power of 0.04 t equal to 24 e, 24 e to the power of minus 0.02 t. Okay, if we divide each side by 4, we're left with e to the power of 0.04 t equal to 6 e to the power of negative 0.02 t. I'm just going to drag that up, so I'm going to remove all this. We don't need this anymore. I'm going to drag that up, so e to the power of 0.04 t is equal to 6 e to the power of negative 0.02 t. Okay. If we also ignore this side as well. Alright. Now we're left with this. Now, we could divide each side by negative 0.02 t. So we could do that. Let's try that. 0.04 t. Divide that by 0.02 t equals 6. But we have to tidy it up now. And so this would technically be e to the power of 0.04, because divides in exponentials, they're kind of like logs, t minus, because we divided it, it's minus 0.02 t is equal to 6, minus and the minus is a plus, so we're left with e to the power of 0.06 t is equal to 6, and now we natural log each side to make this our coefficient. So you get 0.06 t is equal to ln 6 natural log. Then we divide each side by 0.06, leaving us with t is equal to ln 6 over 0.06. Okay, now if I check that, that should be right. If I just try that on the calculator, natural log 6 divided by 0.06. Okay, that's our answer. Rounded up to 1 decimal place, that's what it's asking for. And we know that t is equal to capital T, so t is equal to 29.9 months, because VB and VA is equal to like the metals in a month. Okay, where t is the number of months after monitoring. So t is the number of months after monitoring. That's our answer. Finished.